December 7th, 1941. Ford Island, Pearl Harbor. Smoke rolls across the harbor in thick black columns as Japanese dive bombers scream overhead. Amid the chaos, a handful of Marines are frantically assembling something that should not exist outside an aircraft fuselage. They're pulling AN M250 caliber machine guns from storage crates, weapons meant to be mounted in the wings of bombers and fighters, cooled by 300-mile-per-hour slipstreams at 20,000 feet. Now they're bolting them onto improvised tripods fashioned from training equipment, sandbags, and desperation. Within minutes, these guns will be firing at rates the standard M2 heavy barrel could never match, spitting out rounds at 750 to 850 per minute instead of the ground gun's 450 to 600. The Japanese pilots diving toward Ford Island have no idea they're about to face weapons firing nearly twice as fast as anything the Imperial Navy planners had accounted for in their attack calculations. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. What these Marines are doing violates at least a dozen regulations regarding unauthorized modification of military equipment. Aircraft weapons are not designed for sustained ground combat. They lack the heat dissipation capacity. They lack proper sights for ground targets. They lack mounting systems rated for recoil forces without aircraft structure to absorb the stress. But regulations mean nothing when enemy aircraft are overhead and men are dying. The AN M250 caliber represents an engineering paradox that military bureaucracy spent years trying to resolve. A paradox that field personnel would solve in minutes when survival demanded it. This is not the story of how one mechanic's brilliant innovation changed warfare. This is the story of how hundreds of armorers, mechanics, and desperate servicemen independently arrived at the same forbidden conclusion. That sometimes the best weapon for the job is the one you're not supposed to use. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand why adapting aircraft guns to ground combat was both brilliant and forbidden, you need to understand the engineering compromises that created the AN M2 in the first place. The story begins in 1918, in the closing weeks of World War I, when General John J. Pershing identified a critical weakness in American armament. The United States lacked a heavy machine gun capable of defeating the new generation of armored aircraft and light tanks appearing on European battlefields. Pershing specifically requested a weapon chambered in at least 50 caliber, with a muzzle velocity exceeding 2,700 feet per second. John Browning, already legendary for his M1911 pistol and M1917 machine gun, took up the challenge. Working with Fred Moore and Winchester repeating arms, Browning scaled up his 30 caliber M1917 design to accommodate the massive 12.7 by 99 mm cartridge that would become known as 50 BMG, Browning machine gun. The first prototype, completed in 1918 but not adopted until 1921, was the M1921 water-cooled heavy machine gun. It weighed 121 pounds with its water jacket filled, required a three-man crew to transport and operate effectively, and fired at approximately 450 to 600 rounds per minute. The water cooling system allowed sustained fire without barrel overheating, making it ideal for fixed defensive positions, anti-aircraft batteries, and shipboard mounting. But it was monumentally impractical for aircraft use. Aviation in the early 20s demanded every possible weight reduction. Aircraft engines produced perhaps 200 to 400 horsepower. Payload capacity measured in hundreds of pounds, not thousands. Every ounce devoted to weapons meant less fuel, less ammunition, or reduced performance. The Army Air Service needed Browning's firepower without his water jacket. In 1923, Browning and his team at Colt developed an air-cooled variant. They stripped away the water jacket, reduced barrel thickness, lightened the bolt, shortened the barrel to 36 inches, and modified the feeding mechanism to allow either left or right side ammunition feed, crucial for accommodating the cramped confines of aircraft installations. The result weighed 61 pounds compared to the ground gun's 84 pounds with heavy barrel, a 30% weight reduction. It was standardized for Army/Navy use, hence the AN designation, on October 5, 1933. The official title, Browning Machine Gun, Aircraft, Cal .50, AN/M2, either fixed or flexible, depending on mounting configuration. The weight savings came with profound engineering trade-offs that would shape every subsequent decision about using these weapons. The lighter barrel could not sustain the heat from prolonged firing that the heavy barrel M2 HB tolerated. Armourers were explicitly trained that firing more than 75 rounds in an initial burst, or 25-round bursts thereafter, would overheat the barrel, wear out the rifling, and destroy accuracy. In January 1944, the Army Air Forces adopted chromium alloy barrel liners, stellite, that reduced wear and allowed somewhat longer bursts, but the fundamental limitation remained. Without the cooling effect of high-velocity slipstream, sustained fire would cause catastrophic barrel failure within minutes. The rate of fire increased as an unintended consequence of the weight reductions. A lighter bolt moving through a lighter recoil system cycled faster. Where the M2 HB fired at 450 to 600 rounds per minute, the AN/M2 cycled at 750 to 850 rounds per minute, nearly 40% faster. For aircraft combat, this was ideal. Aerial engagements lasted seconds. A fighter pilot might have only a 3 to 4 second window to hit an attacking aircraft before it broke off or completed its pass. In those brief moments, volume of fire mattered more than sustained fire capability. The AN/M2's higher cyclic rate meant more rounds on target during fleeting opportunities, but that same high cyclic rate created problems for ground use. Higher rate of fire meant faster ammunition consumption, faster barrel heating, faster parts wear. The standard infantry M2 HB could sustain defensive fire for extended periods. The AN/M2, designed for brief bursts in freezing high-altitude air flowing past at 300 miles per hour, would overheat and fail if subjected to prolonged ground combat firing patterns. The other major difference involved mounting and fire control systems. The AN/M2 came in two primary configurations: fixed guns, mounted rigidly in wings or fuselage, fired through electrical solenoid triggers synchronized with the pilot's firing button. Flexible guns, used in defensive positions like waist guns and tail turrets, retained mechanical spade grip triggers, with twin handles and a butterfly trigger activated by the gunner's thumbs. Neither configuration included sights appropriate for ground targets. Aircraft sights compensated for lead angle, deflection, and the relative motion of aircraft. They were useless for engaging ground targets or low-flying aircraft from stationary positions. The weapons existed in vast quantities by December 7, 1941. Production had ramped up dramatically as war approached. General Motors received a $61.4 million contract in September 1940 to manufacture 71,225 machine guns across 4 types, including the AN/M2. Every fighter, every bomber, every patrol aircraft in American service carried multiple AN/M2s. A P-47 Thunderbolt mounted 8 in its wings, a combined cyclic rate of 6,000 to 6,800 rounds per minute. B. 17 flying fortresses bristled with them in every direction: nose, tail, waist, dorsal, and ventral positions. The weapons were everywhere. In aircraft, they were perfectly suited for their role. On the ground, regulations said they should never be used. The morning of December 7th shattered those regulations like it shattered everything else. At 0748, the first wave of 177 Japanese aircraft struck Pearl Harbor and military installations across Oahu. The attack caught American forces comprehensively unprepared. At Awa Mooring Mast Field, the Marine Air Station near Barbers Point, Japanese fighters strafed aircraft parked wingtip to wingtip, an anti-sabotage measure that proved catastrophic when the enemy came from above instead of from within. At Hickam Army Airfield, bombs cratered runways and destroyed hangars while parked aircraft burned. At Ford Island in the center of Pearl Harbor, flames consumed the battleship Arizona, which exploded at 08:06 when a bomb penetrated her forward magazine, killing 1,177 men instantly. The Pacific Fleet's battle line was shattered, 5 battleships sunk or sinking, 3 more heavily damaged, and overhead, wave after wave of Japanese aircraft faced minimal anti-aircraft fire because most of the island's heavy weapons were secured in locked armories, their crews at weekend liberty. But not all weapons were locked away. At multiple locations across Oahu, personnel with initiative and disregard for proper channels began improvising defensive positions using whatever weapons they could access. At Ford Island, Marines and sailors rushed to storage areas and pulled out AN/M 250 caliber and 30 caliber aircraft machine guns. These weapons had been stored for installation in aircraft, for armorer training, for maintenance instruction. Now they became anti-aircraft guns. The challenge was immediate and obvious. How do you mount an aircraft gun for ground fire? The AN/M2 had no tripod mount. It had either a rigid aircraft mounting bracket or a flexible mount designed for installation in turret rings. It had spade grips and a butterfly trigger, not a stock and conventional trigger. It had aircraft sighting systems, not ground gun sights. The solutions varied by location and by the ingenuity of whoever was assembling the position. At Ford Island, photographic evidence shows AN/M 250 calibers mounted on training tripods, instructional equipment normally used to demonstrate weapon assembly and disassembly. Someone had fitted an adapter system that included a rubberized butt pad to absorb recoil, a crude side pistol grip/trigger mechanism to replace the butterfly trigger, and a mounting tower for a telescopic sight. The positions were constructed from sandbags, wood planks, and canvas tarps, whatever materials were immediately available. At Hickam Field, AN/M2s, intended as B-17 defensive weapons, were positioned inside bomb craters, aimed skyward. The craters provided natural protective revetments and stable firing platforms. The guns were aimed using improvised sights, sometimes just the iron sights from other weapons, sometimes simply pointing and firing based on instinct and desperation. 14 miles northeast at Naval Air Station Kaneohe Bay, sailors established temporary fighting positions for AN/M2s pulled from storage. These positions lacked even the minimal mounting systems used at Ford Island. The guns were braced against sandbags or wooden supports, with gunners firing from kneeling or prone positions, absorbing brutal recoil directly through their bodies. One particularly notable action occurred at Ewa Field, where Master Technical Sergeant Emil S. Peters, a 47-year-old Marine, rushed to a Douglas SBD-2 Dauntless dive bomber belonging to VMSB 232. Peters climbed into the aircraft's radio operator/gunner position and used the flexible mount AN/M 230 caliber machine gun to engage attacking Japanese aircraft. The gun was still installed in the aircraft, but Peters was firing it like a ground-based anti-aircraft weapon, traversing the mount to track targets. Before the attack ended, Peters had shot down 2 Japanese D-3A-1 Val dive bombers, later receiving recognition for his action. The immediate tactical results were limited but psychologically significant. The improvised AN/M2 positions did not stop the Japanese attack. The raid achieved its primary objectives. The battle line was devastated. Hundreds of aircraft were destroyed on the ground. 2,413 Americans died that Sunday morning. But the improvised defense demonstrated something crucial that would influence every subsequent battle in the Pacific. Aircraft weapons could function in ground roles when necessity demanded. They fired faster than standard ground guns. They hit harder than standard ground guns when firing armor-piercing incendiary rounds designed to defeat aircraft armor and fuel tanks. They provided suppressive fire that forced attacking aircraft to break off runs earlier or maintain higher altitudes. The weapons worked. They violated regulations. They lacked proper mounts. They overheated faster than they should. But they worked. The question that would preoccupy ordnance officers, unit commanders, and field personnel for the next 4 years was whether working was enough to justify breaking the rules. The formal military position was unambiguous and consistent. Aircraft weapons were for aircraft. Using them in ground roles constituted unauthorized modification of military equipment, voided manufacturers' warranties, created non-standard configurations that complicated logistics and training, and established dangerous precedents where individual soldiers might start customizing equipment based on personal preference rather than tested doctrine. Every military procurement system operates on standardization. Standardization enables mass production, simplified training, efficient logistics, and reliable maintenance. When every M2HB is identical, armourers know exactly what parts fit, exactly what tools work, exactly what procedures apply. When soldiers start adapting aircraft guns for ground use, that standardization collapses. The Ordnance Department's concerns were legitimate from an institutional perspective. The AN/M2 barrel could fail catastrophically if fired beyond its designed parameters. A barrel failure in combat could kill the gunner and anyone nearby. The weapons lacked ground-rated mounting systems. Improvised mounts could break under recoil, sending the gun flying backward into the crew. The higher cyclic rate consumed ammunition at rates that ground logistics couldn't sustain for extended engagements. The weapons required specialized parts: barrel replacements, recoil springs, feed mechanisms for the AN/M2 were different from M2HB parts. Every AN/M2 adapted for ground use meant additional logistics complexity. And there was the precedent question. If you allowed personnel to adapt aircraft guns, what else might they decide to modify? Vehicles? Communications equipment? Fire control systems? Where was the line between battlefield innovation and institutional chaos? But these institutional concerns, valid as they were from a procurement perspective, meant nothing to men who watched their friends die while waiting for authorized weapons to arrive. The tension between institutional process and battlefield necessity would define the AN/M2's war. Because while ordnance officers in Washington drafted memorandums about proper equipment usage, Marines and soldiers in the Pacific were welding mounts, fabricating triggers, and adapting aircraft guns by the hundreds. They were not asking permission. They were not waiting for official programs. They were solving immediate tactical problems using available resources, exactly as Sergeant Curtis Culin would do with his hedgerow cutters in Normandy 6 months later. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The Pacific War created tactical demands that existing weapons simply could not meet. The problem emerged clearly during the Bougainville campaign in November 1943, when the 1st Marine Parachute Battalion landed at Empress Augusta Bay. The Marines faced Japanese defensive positions constructed with masterful use of terrain. Pillboxes built into coral rock and reinforced with logs could withstand direct hits from standard infantry weapons. Machine gun nests positioned in mutually supporting fields of fire pinned down entire platoons. The standard M1919A6 30 caliber machine gun, while reliable, fired at only 400 to 550 rounds per minute. This modest rate of fire meant Japanese defenders could time their movements between bursts, maintaining defensive fire even while under supposed suppression. The Marines needed overwhelming volume of fire that would force defenders to keep their heads down completely, eliminating their ability to return effective fire during assault movements. The M1919A6 could not deliver this level of suppression. Its weight, 32.5 pounds, plus ammunition and tripod, required at least 3 men to operate effectively. In the fluid combat of island warfare, repositioning heavy machine guns under fire proved extraordinarily difficult and dangerous. Marines advancing across coral beaches and through dense jungle needed the supporting weapons to keep pace with rapid maneuver. The standard ground guns could not. Some units on Bougainville began experimenting with captured Japanese weapons, but these required non-standard ammunition and presented training challenges. Others requested additional allocation of Browning automatic rifles, but the BAR fired the same 30-06 cartridge as the M1919, with similar limitations against fortified positions. What they needed was something that fired faster, hit harder, and could be moved quickly. What they had in abundance were crashed aircraft with perfectly functional AN/M2 machine guns that could be salvaged. Private William H. Colby of Gloversville, New York, serving with forces defending Bougainville Island, made the first documented attempt to adapt an AN/M2 for ground combat use during the campaign. Colby's solution was elegantly simple. He salvaged an AN/M230 caliber aircraft machine gun and fitted a bipod to the muzzle. The weapon retained its awkward spade grips and butterfly trigger, but the bipod provided stable firing position that one man could deploy and operate. Just 2 days after the campaign began, on November 3, 1943, Colby's position was ambushed by Japanese infantry. He immediately deployed his modified gun and engaged, fed 30-06 ammunition by Assistant Gunner Private Edward F. Crumlish. Colby's weapon fired at approximately 1,200 to 1,300 rounds per minute, the AN/M230 caliber's standard cyclic rate. The volume of fire was devastating. Japanese troops attempting to close with the position were met with a literal wall of bullets that made movement impossible. The attack broke apart under the sustained fire. Colby's modification had worked, but Colby's design was just the beginning. 2 Marines, Sergeant Milan Mel J. Grevich and Private First Class John Little, recognized the potential and began refining the concept. Grevich, born in Minnesota on May 24, 1924, brought machinist skills from his civilian background. He understood tolerances, stress points, and how to modify existing equipment to perform new functions. When Grevich volunteered for the Marine Parachute Battalions, he joined an elite unit that actively encouraged innovation. The Paramarines trained harder, fought fiercer, and thought differently than conventional Marines. Their culture valued initiative and adaptability, creating an environment where a sergeant modifying government property might be rewarded rather than court-martialed. Grevich and Little took Colby's basic concept and made it genuinely man-portable. They started with AN/M2 aircraft machine guns, both 30 caliber and 50 caliber versions. They fabricated bipods using components from Browning automatic rifles, which provided proven stability and the correct height for prone firing. They cut down M1 Garand rifle stocks to create shoulder stocks that would absorb recoil while allowing the gunner to maintain a proper firing position. The spade grips and butterfly trigger presented the biggest challenge. These components worked perfectly for aircraft use, where gunners stood and used both hands to traverse the weapon while pressing thumb triggers. For ground combat, they were impossibly awkward. Grevich and Little designed a rudimentary solenoid trigger mechanism to replace the butterfly trigger. The solenoid used electrical current to activate the firing mechanism, but in their adaptation, it was activated by a simple mechanical switch mounted where a conventional trigger would be positioned. This allowed the gunner to fire the weapon using normal trigger technique while maintaining proper cheek weld on the stock and sight picture through whatever optical system they could mount. The resulting weapon, nicknamed the Stinger due to its extremely high rate of fire and the metaphorical sting it delivered to enemy positions, retained most characteristics of the AN/M2, but in a package one man could carry and deploy. The 30 caliber version fired at 1,200 to 1,300 rounds per minute. The 50 caliber version fired at 750 to 850 rounds per minute. Both rates far exceeded anything standard ground machine guns could achieve. The weapons were lighter than their ground counterparts. An AN/M2 50 caliber weighed 61 pounds compared to the M2 HB's 84 pounds. With the modifications, a Stinger could be carried and operated by one Marine with an ammunition bearer, instead of the 3-man crew required for standard heavy machine guns. The most famous Stinger user was Corporal Tony Stein, a pre-war machinist from Dayton, Ohio, serving with the 1st Battalion, 28th Marines, 5th Marine Division. Stein carried a 50 caliber Stinger during the Battle of Iwo Jima, which began on February 19, 1945. Iwo Jima was 8 square miles of volcanic ash and rock, defended by 21,000 Japanese troops who had spent months constructing an elaborate network of bunkers, tunnels, and fortified positions. Every cave, every ridge, Every depression in the terrain concealed defensive positions with interlocking fields of fire. American planners had estimated the island would fall in 5 days. The battle would last 36 days and cost 26,000 American casualties, including 6,800 dead. On the first day of the assault, Stein's platoon hit the beach and immediately came under devastating fire from pillboxes and bunkers that had survived the preliminary naval bombardment. Stein, carrying his Stinger and wearing only swim trunks and a helmet because he had discarded his heavy combat pack to increase mobility, began systematically suppressing Japanese positions. The Stinger's rate of fire allowed him to deliver such overwhelming firepower that defenders literally could not raise their heads to aim. While Japanese positions were suppressed, Stein's squad mates could maneuver close enough to destroy bunkers with satchel charges and flamethrowers. Stein made multiple trips across open ground under fire, running back to the beach to retrieve additional ammunition when his weapon ran dry. His Medal of Honor citation, awarded posthumously after he was killed on March 1, 1945, documents 8 separate trips across fire-swept beach to resupply his weapon. Each trip covered approximately 50 yards of completely exposed terrain with Japanese machine gun fire and mortar rounds impacting continuously. Between ammunition runs, Stein used his Stinger to cover advancing Marines, to suppress sniper positions, and to engage any Japanese position that revealed itself by firing. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Stinger was not perfect. The high rate of fire consumed ammunition at unsustainable rates for prolonged engagements. The .50 caliber version fired through its basic load in approximately 30 seconds of continuous fire. Ammunition bearers struggled to keep up with demand during intense firefights. The lighter barrel overheated rapidly. Stein and other Stinger operators were trained to fire in short bursts, but the tempo of combat on Iwo Jima often demanded sustained fire that pushed the weapons beyond their designed parameters. Barrels warped, springs fatigued. Feed mechanisms jammed from heat expansion. The weapons also lacked the durability of standard ground guns. The M2HB was designed to withstand the punishment of ground combat, the impact of being dropped, the stress of being dragged across rough terrain, the exposure to dirt, sand, and moisture. The AN/M2 was designed for relatively clean aircraft environments where maintenance occurred after every mission. Exposing these weapons to volcanic ash, salt water spray, and the general filth of ground combat led to accelerated wear and frequent maintenance issues. But these limitations mattered far less than the weapon's effectiveness. The Stinger could deliver firepower that no other man-portable weapon could match. It suppressed enemy positions that standard machine guns could not adequately suppress. It provided covering fire that allowed Marines to advance when they would otherwise have been pinned down. It saved lives. For 6 weeks on Iwo Jima, the handful of Stingers in Marine hands gave units fighting on the bloodiest beach in Marine Corps history a weapon that helped them survive, helped them win, helped them accomplish a mission that cost more American lives than any other Pacific battle. The adaptation of AN/M2 aircraft guns for ground combat was never officially authorized. No formal procurement program existed. No technical manuals were written. No training courses were established. The weapons that did exist were built in field workshops by mechanics, armorers, and Marines with machining skills. Grevich built perhaps 6 functional Stingers during his service. Other units created their own variations using locally available materials and their own design solutions. Some installations were more successful than others. Some were dangerously unstable. Quality control was non-existent because there was no formal program to control. After the war, the institutional response was swift and predictable. The weapons were destroyed. Military bureaucracy, uncomfortable with weapons that existed outside official channels, ordered the Stingers and similar adaptations broken up and disposed of. The reasoning was sound from a logistics perspective. These non-standard weapons required non-standard parts, non-standard maintenance, non-standard training. In a peacetime military focused on standardization and efficiency, they had no place. But destroying the physical weapons did not destroy what they represented. The Stinger and similar AN/M2 adaptations demonstrated principles that would echo through every subsequent American conflict. First, soldiers in contact with the enemy often understand tactical problems better than engineers and planners thousands of miles away. The Marines who created Stingers were not weapons designers. They were combat troops who recognized that existing weapons were inadequate and that better solutions were available if regulations could be bypassed. Second, rigid procurement processes can cost lives. The institutional path to fielding new weapons involved requirements definition, competitive bidding, prototype development, testing, evaluation, and production. This process typically required years. Combat troops needed solutions in days or weeks. Third, bottom-up innovation works when institutional processes fail. The Stinger was never part of any official program. It emerged from field necessity and individual initiative. Fourth, sometimes the best solution is the one you build yourself from available resources, rather than the perfect solution that might arrive eventually through proper channels. These lessons influenced subsequent conflicts, though often incompletely. Vietnam saw American forces create gun trucks, improvised armored vehicles built by welding steel plating onto standard cargo trucks. These unauthorized modifications solved immediate tactical problems related to convoy security, but they also generated the same institutional resistance the Stinger had faced 20 years earlier. Iraq and Afghanistan demonstrated the pattern again. When roadside bombs became the primary threat to American vehicles in 2003 and 2004, soldiers began welding scrap metal and stacking sandbags on Humvees for protection. These improvised modifications preceded the official MRAP program, Mine-Resistant Ambush-Protected Vehicles, by years. The MRAP eventually became official doctrine involving billions in procurement spending. But initial problem identification and early solutions came from soldiers and junior mechanics, not Pentagon acquisition offices. Modern military doctrine now explicitly incorporates rapid fielding initiatives and urgent operational needs processes, designed to bypass normal procurement timelines. These programs exist partly because of lessons from Normandy, Vietnam, Iraq, and yes, from the Stinger. Recognition that waiting for perfect official solutions means accepting unnecessary casualties. The Marine Corps established its rapid response process in 2005, explicitly citing the hedge cutter and similar World War II innovations as precedent. The Army created similar structures. These programs have shortened the gap between problem identification and solution deployment from years to months, though still not to the days or weeks that characterized innovations like Grevich's Stinger. The broader question remains unresolved. How do military institutions balance the need for standardization against the reality that frontline personnel often see problems first and most clearly? How do they preserve space for individual initiative without descending into chaos, where every soldier modifies equipment based on personal preference? The tension between institutional process and battlefield necessity will never be fully resolved because the competing demands are both legitimate. Standardization enables efficient large-scale operations. Innovation enables survival when circumstances change faster than institutions can respond. The AN/M2s war was fought in this tension. Officially, aircraft weapons were for aircraft, ground weapons were for ground use. The categories were distinct and the boundaries were clear. Unofficially, hundreds of mechanics and armorers across the Pacific adapted aircraft weapons for ground combat because the official weapons were inadequate and because saving lives mattered more than following procedures. They built their modifications in field workshops using salvaged materials. They trained themselves and their fellow troops in weapons that did not appear in any manual. They pushed their creations beyond designed parameters because combat demanded it. Tony Stein died on March 1, 1945, 27 years old, during fighting for Hill 362A on Iwo Jima. He was killed by Japanese sniper fire while directing tank operations to support his platoon's advance. His Medal of Honor citation specifically mentions his Stinger, describing how he used his personally designed aircraft-type weapon to provide covering fire that allowed his unit to advance against fortified positions. The citation does not mention that the weapon was unauthorized. It does not mention that using it violated regulations. It simply acknowledges that Stein used what worked, regulations be damned, and that his actions saved lives. Milan Grevich survived the war and lived into old age, carrying memories of volcanic beaches, improvised weapons, friends lost, and battles won. He never sought recognition for creating the Stinger. He never pushed for official acknowledgement of his contribution. To him, the weapon was simply what needed to be done. One Marine's contribution to helping other Marines survive and accomplish their mission. This humility, characteristic of his generation, perhaps obscures the significance of his achievement, but it also reflects the values that made the achievement possible. Grevich did not build the Stinger for recognition or reward. He built it because Marines were dying for lack of adequate fire support, and he could do something about it. The Stinger never became official. It never appeared in weapons manuals or equipment tables. It never received a formal designation or procurement budget. No modern military uses weapons based on the Stinger design. No institutional memory preserves detailed knowledge of how they were built or employed. The weapons themselves were destroyed decades ago by an institution uncomfortable with hardware that existed outside official channels. But what the Stinger represented endures in military culture. The understanding that sometimes the best solution is the one you build yourself. That regulations exist to serve the mission rather than the mission serving regulations. That saving lives and accomplishing objectives matters more than bureaucratic comfort. The AN/M2 aircraft machine gun was designed to arm fighters and bombers, to engage enemy aircraft at 20,000 feet, to operate in 300-mile-per-hour slipstreams and sub-zero temperatures. It was never designed for ground combat. Using it in ground roles violated regulations, voided warranties, created logistics complications, and established dangerous precedents. But when Japanese aircraft appeared over Pearl Harbor, when Marines hit volcanic beaches on Iwo Jima, when soldiers faced tactical problems that existing weapons could not solve, the AN/M2 became exactly what was needed. Not because engineers had designed it for that purpose, but because desperate men with welding torches, improvised mounts, and complete disregard for proper channels made it work anyway. The lesson transcends any specific weapon or any specific conflict. Innovation under pressure often originates from the bottom, not the top. The greatest military organizations are those that can maintain rigorous standards while still empowering individuals to solve problems creatively. They are organizations that value initiative even when it challenges established procedures, that reward innovation even when it exists outside official channels, that trust their people to do what needs to be done even when regulations might suggest otherwise. The AN/M2 earned its place in history not through official programs or institutional recognition, but through the actions of men who recognized that survival and mission success mattered more than following rules. Designed for different circumstances. Every Marine who faced fortified positions on Pacific Islands, every sailor who improvised anti-aircraft defenses at Pearl Harbor, every mechanic who fabricated mounting systems from scrap materials, they understood that sometimes the unauthorized solution is the only solution that arrives in time to matter. This is the AN/M2's true legacy, not the technical specifications or the rate of fire statistics, not even the confirmed kills or the battles won. The legacy is the principle that when regulations conflict with necessity, when institutional process moves too slowly to save lives, when existing solutions prove inadequate for emerging problems, individuals with initiative and courage can create better answers. That this innovation carries risks, that it generates institutional resistance, that it creates complications, but that ultimately, in war, as in every human endeavor where lives depend on solving problems faster than bureaucracies can process paperwork, the ability to innovate matters more than the ability to follow procedures. The mathematics of firepower tell a story that procurement committees never calculated. When a standard M2 HB heavy barrel opened fire at 500 rounds per minute, it delivered 8.3 rounds per second. Respectable firepower by any measure, enough to suppress infantry, disable light vehicles, and threaten low-flying aircraft. But when an AN/M250 caliber opened fire at 800 rounds per minute, it delivered 13.3 rounds per second. That 60% increase in rate of fire created a qualitative difference in tactical effect that transcended simple arithmetic. Japanese troops defending fortified positions on Pacific Islands had learned through bitter experience to time their movements between machine gun bursts. When an M1919A6 or M2HB fired, defenders could count the rhythm of fire, recognize the pause for barrel cooling or ammunition reload, and use that pause to reposition, return fire, or prepare grenades for counterattack. The timing was precise because the weapons were consistent. American machine guns fired at predictable rates using standardized doctrine. Japanese defenders adapted their tactics accordingly. The AN/M2 destroyed that adaptation. Its rate of fire was fast enough and sustained enough that no pause existed for exploitation. A 5-second burst from an AN/M250 caliber put 66 rounds downrange. Those 66 half-inch diameter projectiles, each capable of penetrating light armor and concrete, created a beaten zone where survival was impossible and movement was suicide. Japanese troops who had successfully timed their actions around standard machine gun fire found themselves facing a weapon that fired so fast their established tactics became death sentences. This is why Tony Stein could advance across open ground on Iwo Jima, not because he was immune to enemy fire, but because his Stinger delivered such overwhelming suppression that Japanese defenders could not effectively return fire while his weapon was active. The Medal of Honor citation describes him as attacking pillboxes alone, but this description obscures the tactical reality. Stein was not alone. He was covered by the most devastating portable suppressive fire weapon available to American forces in 1945. His repeated ammunition runs were necessary because that level of firepower consumed ammunition at rates ground logistics had never been designed to sustain. The ammunition consumption problem reveals another dimension of the adaptation challenge. Standard doctrine for the M2HB allocated approximately 500 rounds per gun for a typical engagement, with additional ammunition available for extended operations. This allocation was based on the weapon's rate of fire and expected engagement duration. When units began using AN/M2s in ground roles, that same 500-round allocation lasted perhaps 60% as long due to the higher cyclic rate. Multiply this across an entire unit, and the logistics burden increased substantially. Ammunition supply points had to stock more rounds. Transport capacity had to be allocated differently. Resupply schedules had to be accelerated. The Pacific Theater's logistics were already stretched to breaking points by distance and island-hopping campaigns. Every bullet, every can of food, every gallon of fuel, every piece of equipment traveled thousands of miles by ship to forward bases, then by landing craft to invasion beaches, then by hand carry or vehicle to frontline positions. Adding 30 to 40% more machine gun ammunition to this logistics pipeline was not trivial. It required real ships, real cargo space, real labor to load and unload. The institutional resistance to AN/M2 ground use was not merely bureaucratic obstinance. It reflected genuine concerns about sustainable logistics. Yet, the weapons proliferated anyway because the alternative was unacceptable. Marines pinned down by Japanese fire did not care that their Stinger consumed ammunition faster than doctrine allowed. They cared that it kept them alive. Supply officers who worried about ammunition consumption rates were not the ones dying on volcanic beaches. The men who were dying wanted the most effective weapons available, and they were willing to accept logistics complications as the price of survival. This dynamic, the tension between institutional efficiency and battlefield effectiveness, appears throughout the history of military innovation. The British Longland pattern musket, Brown Bess, served for over a century, partly because standardization enabled efficient logistics. But soldiers in specific engagements would have benefited from weapons with better range, accuracy, or rate of fire. The institution chose sustainability over optimization. The AN/M2 adaptation represented the opposite choice, battlefield effectiveness over institutional efficiency, made by the men whose lives depended on the outcome. The post-war destruction of these weapons was inevitable once the choice was no longer between efficiency and survival. In peacetime, military organizations default to standardization because the costs of non-standard equipment exceed the benefits when combat is theoretical rather than immediate. Training becomes more complicated when weapons vary between units. Maintenance becomes more difficult when parts are not interchangeable. Logistics becomes more expensive when supply chains must stock multiple variants. These complications are tolerable during existential conflict. They are not tolerable during peacetime force management. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.